how do we use the comparison test to show that the improper integral going from 1 to infinity of 1 over x plus e to the x converges or not? Here, we have two choices. We will see if we can use one of them to compare with that and argue if this right here converges or not. First off, notice this right here is just that portion we ignore the e to the x. And this right here is just that portion we ignore the x right here. And you see, once we ignore them, these two right here are so much easier. And the truth is, we really have to use the comparison test because we cannot integrate this with any of the integration techniques that we know in Calc 2. But anyway, have a look. For the first one, integral going from 1 to infinity of 1 over x. This is the same as saying 1 over x to the first power. So we know this is the p integral test, which is p equals 1, which is less than or equal to 1. So we can say this right here diverges. Now, this is the check that we are going to do. Let's write that down right here. Let's go ahead and put down the one that we're trying to do on the left, which is the integral going from 1 to infinity of 1 over x plus e to the x. And because we have a divergent integral, so we hope to show that this right here is bigger than or equal to this divergent integral, which is the integral going from 1 to infinity of 1 over x dx. And the truth is, this right here diverges to infinity. So the idea is, if we can show that this is bigger than or equal to that, then we can say this has to be a bigger infinity, therefore we can say this right here also diverges. But right here we don't know yet, so let's put down a question mark. And the truth is, everything is positive, so let's indicate that right here. And usually I don't ask my students tricky questions, so you can be sure that the functions will be positive on this interval that we care. Alright, now we are just going to compare the functions inside because both integrals are going from 1 to infinity. So let's look at 1 over x plus e to the x. Is this bigger than or equal to 1 over x? Well, again, we just care about this interval, which is x is bigger than or equal to 1. Well, we don't know this yet, but in fact we can see it really well because you see that x plus e to the x is bigger than x. So the whole thing here is actually smaller. Therefore, this right here is actually false. Yeah, but anyway, a lot of us like to do cross multiplication. Let's go ahead and cross multiply if you would like. This will be easier. But because everything is positive, when we cross multiply, we do not have to flip the inequality symbol. X times 1 is just x. Is this bigger than or equal to that times that, which is x plus 1? I mean x plus e to the x. I think now this is much more clear, right? You see this right here is actually false. Unfortunately, this right here is a false inequality. What does this mean though? Does this mean that we set out the inequality incorrectly? Should we have put it down like this instead? No. This right here, it was what we hope to show, because once again, we hope to show that this is bigger than or equal to the past infinity that this diverges to. But unfortunately, it's not true. Therefore, this right here, we cannot draw any conclusion. So, be really careful with the inequality and be really careful with the things that we are writing along the way. So, unfortunately, we cannot use this improper integral to do the comparison with that. So that's what this question is all about. Now, let's try this one. Okay, unfortunately, this is not a p integral, but it's not bad at all because we can integrate this. To do so, we integrate from 1 to infinity. Look at this as e to the negative x. And integrating this, we get e to the negative x. But remember to divide it by the derivative right here, which is negative 1. Divided by negative 1, we can just put on negative right here. And then we plug in, right? 1 and infinity. Plug in infinity first. We get negative e to the negative infinity. That's the first term. And then minus negative e to the negative 1. Okay. E to the negative infinity is 0, so the whole thing here is 0. That's very nice. So that way you know this right here converges. Negative is positive, and then e to the negative 1. All in all, we just get 1 over e. And this is really cool because you see, when we integrate from 1 to infinity of 1 over e to the x, we actually get 1 over e, which is really cool. But you know this is a finite number, So this right here converges. Okay, because this time we have a convergent integral, so we actually have to set out a different inequality. Let's go ahead and do the check. Let's go ahead and put down the one that we're trying to do right here, which is the integral going from 1 to infinity, 1 over x plus e to the x. This time, we hope to show that this right here is smaller than or equal to the one that we know, which is the integral going from 1 to infinity of 1 over e to the x. Because this right here is a positive finite number, if we can show this right here is smaller than or equal to a positive finite number, this right here has to be a smaller positive finite number. Therefore, we can say this right here also converges. But be really careful though, because the truth is, negative infinity is indeed less than or equal to the positive finite number. We don't want that to happen. That's why we usually just indicate this kind of inequality at the end. In fact, because we know this right here is positive, so you know we will never get negative infinity from here. But anyway, we hope to show that this is true, so let's put down a question mark. And again, do the same thing. Compare the functions. 1 over x plus e to the x. Is this less than or equal to 1 over e to the x? And the interval that we care is just x is greater than or equal to 1. This time is true. And again, if you would like, you can just cross multiply to make everything really clear. This times that is that. Is this less than or equal to this times that, which is x plus e to the x? Yeah, this is so true now, right? It's really clear now. So, yay. This time, we end up with a true inequality. Therefore, we can actually use this right here to draw conclusion. And the conclusion is the following. Let me write that down. The conclusion is, let's go ahead and write down the one that we're trying to do again. The integral going from 1 to infinity of 1 over x plus e to the x. And let's use the word also. This right here, also. Also what? Well, the conclusion is that we know that right there also converges. And this is a very nice word to use when you are doing the comparison test, because when you use the word also, you see, they must have the same conclusion. This right here converges. This right here also converges. You can never say, this right here converges, this right here also diverges. That just doesn't sound right. Hey, you're wearing a white hoodie. I'm also wearing a black hoodie. That doesn't sound right, see? So use the word also, that will help you to remember to write down the right thing. So this right here also converges, and perhaps you can say by the comparison test or the comparison theorem, depends. But anyway, that's it. So let me just box this right here. This is the integral that we can use to do the comparison with that, and we can draw conclusion. Hopefully this video helps, and you can check out my next video because I'll show you another example just like this.